Mountains are supposed to reach equilibrium, a stable state where erosion matches the forces holding them up. The Himalayas are in equilibrium, the Rockies are in equilibrium, but the Appalachian Mountains, they're in a state of geological disequilibrium and have been for potentially hundreds of millions of years. The ridges erode at different rates than the valleys. Rivers are constantly capturing each other. Drainage divides are migrating. The entire system is permanently out of balance, and geologists now believe the Appalachians may never stabilize. This is what's actually happening beneath the oldest mountains in North America. Dynamic equilibrium is the gold standard for most mountain ranges on Earth. In places like the Himalayas, the math is clear. Tectonic uplift pushes the land skyward at rates that can reach 5 centimeters per year, while erosion, driven by monsoon rains and relentless rivers, wears the peaks down at nearly matching speeds. The result is a landscape in constant motion, but one that hovers near a steady state. The ridges remain steep, valleys stay deep, and the overall shape of the range persists for millions of years. Scientists capture this balance with a mass balance equation. The rate of uplift equals the rate of erosion. In the Himalayas, this dynamic has played out for tens of millions of years, with sediment pouring into the Ganges and Brahmaputra at rates that nearly mirror the mountain's upward push. The Rocky Mountains tell a similar story, though on a different timescale. After their last major uplift pulse during the Laramide orogeny, the Rockies began a slow process of topographic smoothing. Nick points, those abrupt drops in river profiles, retreat upstream over spans of 10 to 20 million years, gradually erasing the scars of tectonic upheaval. Over these long intervals, rivers carve new valleys, hill slopes creep downward, and the landscape edges closer to equilibrium. In both cases, the system is dynamic but balanced, with uplift and erosion locked in a long-term standoff. This is what geologists expect from a mountain range that has reached its steady state, a landscape always changing, but never truly out of balance. The Appalachian Mountains are not what most people imagine when they think of an ancient range. After the last great pulse of tectonic stretching and rifting ended around 180 million years ago, the region should have begun a slow slide toward geological calm. But the story didn't play out that way. Instead, the Appalachian Range has spent the last 180 million years in a state of lingering imbalance. The crust stopped rising with any force once the Triassic rift activity faded, yet the landscape never flattened out into a true peneplain. Instead, something subtle but powerful took over: isostatic and flexural rebound. As the thick layers of sediment eroded away, the crust responded by lifting slowly at a rate of about 0.1 millimeters per year. It's a modest, almost invisible uplift, but over millions of years, it adds up. Dr. Thomas, a leading geologist in Appalachian tectonics, points out that this rebound is not a simple after effect. It's a persistent force, nudging the land upward long after the original tectonic drama has faded. The Appalachian crust, some of it nearly 480 million years old, keeps responding to the removal of rock above, never quite settling into a steady state. The result is a region where the old rules of equilibrium break down. Ridges and valleys refuse to even out, and the landscape remains restless, always adjusting but never arriving at balance. This is the Appalachian puzzle, a mountain range that should have found peace, but instead keeps shifting under the weight of its own past. Numbers cut through the Appalachian mystery. Ridges and valleys are eroding at rates that simply do not match. Dr. Maya Patel, a geomorphologist specializing in cosmogenic nuclide analysis, has assembled a striking set of bar graphs from 10B measurements across the central Appalachians. Her data show that ridge crests are wearing down at just 10 to 20 meters per million years, while adjacent valleys are deepening at about 50 meters per million years, 2 to 5 times faster. The difference isn't subtle. It's a clear, measurable imbalance. Over 1 million years, net relief grows by as much as 27 meters, with valleys racing ahead and ridges lagging behind. These results are not outliers or artifacts of a single site. They come from dozens of locations, each carefully sampled and cross-checked using accelerator mass spectrometry and the Lalstone scaling model for 10B production. The uncertainties are well constrained, yet the story remains the same. The landscape is not evening out. Instead, it's becoming more rugged, more divided, and more restless with every passing epoch. This is disequilibrium, quantified in meters and measured in the rocks themselves. The boundary that divides Atlantic-bound rivers from those draining toward the Gulf is not the fixed line many imagine. Modern GPS surveys and careful analysis of historical USGS maps reveal that the eastern continental divide has shifted by measurable distances within a single human lifetime. Between 1940 and 2020, GPS data show the divide moved 600 meters westward, a change confirmed by repeat measurements with a positional uncertainty of just 1/10 of a kilometer. Earlier, a comparison of USGS topographic sheets from the 1930s and 1950s documented a 1.2 kilometer westward jump in the Allegheny Plateau. But the most dramatic shift followed the 1911 Potomac flood, when field teams recorded the divide leaping 3 kilometers east in response to a river capture event triggered by catastrophic flooding. Archival voices from the 1912 USGS flood report describe the sudden redrawing of watershed boundaries, with headwaters rerouted and entire drainage areas reassigned overnight. These migrations, mapped line by line across generations, prove that the watershed divide is a living, moving boundary, one that responds to the slow grind of erosion, abrupt floods, and the relentless tug-of-war between neighboring rivers. The geometry of the drainage system itself is caught in a state of ongoing adjustment, with each shift echoing through the landscape for thousands, even millions of years. Rivers in the Appalachians are restless forces, shaping and reshaping the land with every passing year. The New River, winding through West Virginia and Virginia, is older than the mountains themselves. Geologists trace its incision back at least 350 million years. In 1853, John H. Cliphart noticed the river's straight valleys and its refusal to follow the rules of the ridges, slicing through as if the hills were afterthoughts. Today, LiDAR data and cosmogenic nuclide dating confirm what Cliphart saw. The New River is an ancient antecedent, carving its path before the mountains ever rose. But age is only the beginning. The New River and its neighbors are constantly at work, capturing streams and redrawing boundaries through river piracy. When one river erodes its headwaters faster than another, it can steal entire drainage basins. Nick points, those abrupt drops in a river's profile, mark the scars of these captures. LiDAR tracking shows nick points in the central Appalachians retreating upstream at 0.2 meters per year, shifting the very shape of the land. Earl Coon Carter remembers the water eating away at the hill year by year, changing the world he knew. No single force explains why the Appalachians refused to settle. 4 factors, each running on its own clock, keep the region in flux. The first is the rugged mix of rocks. Quartzite ridges, hard as iron, erode at just 10 to 20 meters per million years. In contrast, the softer schists and phyllites below wear down 2 to 5 times faster. This difference means valleys deepen while ridges stand firm, sharpening the relief instead of smoothing it. Beneath, seismic tomography uncovers a broad, low-velocity zone, a warm, buoyant mantle patch under the central range. This anomaly drives subtle uplift, about 0.05 millimeters each year, nudging the land upward even as erosion grinds it down. The Pleistocene's wild climate swings unleashed pulses of erosion and sediment, creating bursts of change that still echo today. Meanwhile, isostatic rebound lifts the crust as rock is stripped away, ensuring the mountains remain restless, never reaching true equilibrium. Thermochronology peels back the curtain on Appalachian time, revealing a mountain range that has never truly rested. Zircon and apatite cooling ages show that the crust beneath these ridges has been exhumed, uplifted, and eroded for nearly 480 million years, stretching back to the Ordovician. Even after the last tectonic pulse faded 180 million years ago, the land kept moving. Flexural rebound, the slow rising of crust as overlying rock is stripped away, has quietly shaped the region for at least 150 million years. Dr. Thomas describes how, in the southern Appalachians, rocks buried deep during the Jurassic began their long return to the surface in the Cretaceous. Apatite youth, he ages cluster between 80 and 60 million years, marking a phase of rapid exhumation as the crust cooled and rose. But the process never stopped. Each time a new layer eroded away, the crust flexed upward again, refusing to settle. The landscape is a palimpsest, new patterns etched over ancient scripts, with no final draft. The Appalachians are not a monument to the past, but a living record of adjustment, written in the language of deep time. The Appalachians remain a work in progress, caught between shifting rivers, rising ridges, and relentless erosion. Disequilibrium isn't a flaw, it's the engine of change. For those who call these mountains home, their restless terrain is proof. Even the oldest landscapes refuse to stand still. Thanks for watching.